So right now we're going to be looking at the problems that can arise when people repair their floors. What happens is there'll be dry rot, there'll be a kitchen remodel, whatever it is. There's some reason they'll replace the floor, with plywood. So there's the old floor that's made out of oak and Douglas fir planks or whatever it is. They tear that part of that up and they replace it with plywood. And that can be a problem because it can interfere with the transfer of earthquake forces through the floor into the foundation, and we're going to go look and see how that's repaired right now. So right now you can see how a floor is being repaired with plywood. Normally it's because of dry rot, or they got really wet, or just who knows why, kitchen remodel, anything. So anyway, this piece of plywood is replacing a part of the old floor. So the old floor used to be, this is the old floor right here. You see these diagonal boards, there's one right here, one right here. This whole thing is diagonal boards. That's called diagonal sheathing. And diagonal sheathing is actually a rated shear wall material for walls, and it's very strong. It resists earthquakes pretty well, and it transfers forces out to wherever the foundation might be. So that's why these floors are very important to keep intact. So what's happened here is the contractor, he cut a part of the floor out. So he ran a saw right here, and now this piece of floor right here probably had the nails right in the middle, and they were taken out. And so when they're taken out, this piece of floor is no longer connected to this piece of wood. And then when he puts this piece of plywood in, he might put 1 or 2 nails or 3 nails. He's not going to worry about earthquake forces. He just wants this piece of plywood to sit on this board, and then he can put in his plumbing and his, whatever he's going to do at that point, new floor. So what's happened is he's really seriously compromised the ability of this house to resist earthquakes. So even if on this side over here where the foundation is, let's say there's a bunch of bolts and there's all kinds of plywood and there's everything you can imagine, well, so what? If the earthquake force can't transfer through the floor, in other words, if it can't come this way, transfer all the way out to where the the foundation is, it's not going to do any good. Now this floor is extremely important in transference because basically most of the weight of the house is there. Most of the actually the roof, if there's a second story, if the walls inside the make the bedrooms and all that stuff, the furniture, there's tons of weight, and it's all being transferred out through that the floor, and if there's a break in the floor, then it won't work. So we've developed a repair to address that, and I'm going to show you what that is right now. So let's review one more time why this kind of repair is a problem. What they've done here is when they did this repair, they tore all the nails out right here. And so if we take this piece of plywood and we set it on top, it's going to be supported by this board here and then this board here. We set it down there and we put a few nails in it. What's going to happen is it's going to come this way, it's going to not be connected to this, so it has nowhere to go because they're just simply not connected. They're not glued, they're not nailed, there's nothing between them. So what we have to do is we need to figure out a way to connect this board to this new piece of plywood so that the earthquake force will transfer as we want. So let me show you, if this was repaired in a particular way, it would have worked as is, but no one ever thinks of it. When contractors are working on a floor, they're flooring contractors. They're not worried about earthquake transference through the floor. They won't even know about it. So if when they did this, they had replaced all the nails, let's say they put a nail every 2 inches along this wall, along this floor I mean, and then when they put the piece of plywood in, they would have done the same thing here. So this would have had a piece of plywood that extends here, across here, and then there would be a nail every 2 inches into the plywood, a nail every 2 inches into this board right here. And what that would do, it would connect the two together, because what would happen is earthquake forces are coming out this way, they hit the nails, the force in the nails go into this piece of wood, and then they go from that piece of wood into the nails that are attached to this piece of wood, the plywood, and then it continues on and it transfers to where the foundation is. That may not be clear to you, but I think once you see what the repair is, it will be very clear to you. So anyway, I developed a repair for this. This was a problem. I'd been scratching my head for a long time. I had no idea, what I was going to do about it, and I finally figured something out. Had it reviewed by some very high-powered structural engineers, and they said it was, a really good idea. So anyway, I'm going to share that with you because that's what we are doing on your house. So this is what your floor originally looked like before there was any kind of repair. So here's the floor. Here's one floor joist. Remember there was that piece of wood where I said the nails from the plywood can go into it, and also the nails from the old floor can go into it, and they had cut the nails out. Well, that's called the floor joist. And anyway, that's your old floor was nailed to it like this. So this, here's the original. They call them subfloors because the oak and other things are on top of it. But we have a nail here, and we have a nail here, and we have a nail here. So this entire floor, it's all connected. Earthquake forces are going to come right along here, no problem at all, no breaks. They come right here. They go into this end joist, which is what your house has, and then we put in this shear transfer tie, which you learned about later. So this kind of retrofit is pretty simple. We just put in the shear transfer tie and we're done, because we're not worried about transfer up here because the floor is already all fixed and nothing we have to worry about. So we repair this with adhesive, and it works really well. So I'm going to show you how that works. So this is the magical Howard Cook repair that I just told you about, and here is the original floor. We call that a subfloor again because we put carpet, or usually it's oak, over the top of it. And then here's the piece of plywood we put in. So what happened here is we took the subfloor out from here to here, this joist here, and it subfloor used to be nailed into here, and needs to be nailed into here. And so they took this piece of subfloor out and they replaced it with the plywood. Now what they did is, when they had the original subfloor, it had nails that came through the center of it. And then when they cut it out, they would have cut through those nails and pulled them out. So now this subfloor is not connected to this joist anymore. And naturally it's not connected to the plywood because there's just this gap right here, so they're disconnected. So this is a questionable connection. We don't really know what's going on here. Now, if the contractor had really been worried about earthquakes, which pretty much never happens, you would find a bunch of nails right here, and you'd find a bunch of nails right here, and then that would connect the plywood and the subfloor together through the nails. And the other thing is, we come over here, in order to take out the subfloor, we'd have to pull it out from this end joist right here, which is where it's connected to the top plate and the shear walls and all the foundation, all that stuff. So this is a really critical connection here, where the subfloor is connected to the joist. So this connection here has also been compromised. So we have to worry about that. What is going on now and how are we going to repair it? So this is the repair. You take a block, it's pretty long, it's 12 feet, 14 feet, something like that, pretty long block. And we put that here and we glue it to the plywood, and then we glue it to the end joist right here. So now this piece of plywood is connected to this. And so earthquake force comes this way, it goes into the block, it goes into this side of the block, and then it goes into the joist. Then we put in our usual shear transfer tie, and we got our plywood and all the other stuff down there. So we have connected this piece of plywood to this joist, and then the shear transfer tie and everything else. So this repair, this connection has been fixed. Now we come over here and we do the exact same thing. We take a block, we glue it here, we glue it here, and now this piece of plywood right here is connected to this joist, and it's connected to this joist, just as if it was a piece of the new subfloor. It's connected here and it's connected here like it should be. Then what we do is we take another block and we glue it here and we glue it here. So now this is connected to this joist through the block. So let's go through the whole load path again. Original subfloor is connected to this block through the glue. The block is connected to this joist. This joist is connected to this block through the glue. This block is connected to the plywood through this glue right here. That plywood is connected to this block through this glue, and this block is connected to the floor joist through here. So all the earthquake force goes finally through all those glued connections right here where we want it to go. And then we have our typical shear transfer tie connection right here, and then it goes into what you saw the top plate earlier, goes into the shear wall and down into the foundation, and we've fixed this problem. Now, I have never seen on any house I've ever looked at that's been retrofitted anyone ever spotting this, anyone even thinking about it. So this is the sort of thing that, being what they call a retrofit propeller head, I used to go under a house and I look up there and go, man, there's something not right. It's not going to transfer like it should. In order to get a good retrofit out of this, I'm going to have to repair this somehow. And I really thought about it a long time, and I finally came up with this repair, and I think it's the only one that I can imagine would ever work. So anyway, we're going to have to do that on your house. And just want to make it clear, because this is sometimes hard for people to understand, and this is what our repair is going to be. So I hope you enjoyed this video. You're not going to see this particular retrofit technique mentioned anywhere. I've never seen it in print. I've never heard any other engineer talk about it, but it's a really critical, connection to take care of, as you can see. Now, it's these video series. If you see anything that you think I didn't get right, said something that's not correct, please let me know. If you have any comments about anything, especially any questions, it would be great to hear what those questions are. I will answer every single comment, and there will probably be other people who want, have the same question, and they could also benefit from your question and my answer as well. So if you have any comments, I do answer all comments. Love to hear from you, and there will be more videos coming. You can subscribe, and you'll get you'll be alerted about those. So anyway, I really hope you got something out of this, and I know if you're a contractor or an engineer, you'll remember this when you need to.